So yeah, this is the problem. Count the number of good subarrays. So you need to return at least k pairs. You need to return the count of good subarrays such that there are at least k pairs of indices such that both the elements are equal, right? Such that both the elements are equal. So let us understand this. So if you take the sample case 2, then the array was this and your k is 2, right? So can I say my good subarray will be a window of this, because here it is forming two pairs, here it is forming at least two pairs, right? Because what is a pair? If both the elements are equal, or if both the elements are same, can I say it is one pair? So in the question, he has given us k equal to 2. In that subarray, there has to be at least k pairs such that it satisfies the condition, right? So this is a good subarray, and what will be other? And it can be this, and it can be even this, and it can be even this, right? So we are total. If you can observe, we are getting total four good subarrays such that, see, it is a one pair, it is a one pair, and it is another pair. You can include them. See, if you are going to take this window, still this window has two pairs. If you take the whole window, still it has at least two pairs such that both the elements are same. So you need to count in that manner. So what we will be doing, initially you take two iterators I and j pointing to the first element, and now you start counting the frequency of each element. See, now you're standing on 3 and increment your frequency in your corresponding map, and then you check whether it is making any pair with the previous elements or not. Since it is a first element, it is not making any pairs with the previous element, right? See, here I was updating my frequency map. That is, our 3's frequency is 1, and now I'll increment my j, and now again check, and now again increment my 1 frequency, and I'll again check whether it is making any pairs with the previous elements or not. Since it is not making any pairs, now I again increment my j, and I again increment my frequency, and now again increment my j to the next. You can see this 3 is making one pair with the previous 3, right? It is making one pair with the previous 3. Now what you'll do, you just increment your 3's frequency, that is 2. Now can I say it is forming frequency minus one pair? Because see, 3's frequency is 2. Can I say it can pair with the n minus 1th elements, which is its frequency? So now my pairs will be incremented to 1. Now I'll check, are there are at least k pairs in my subarray such that it is satisfying my condition, so that we can count it as a good subarray. Since our k is 2, it is not satisfying our condition to count it as a good subarray, right? So we'll again move our iterator to the next element, and now you again increment your frequency of 2 to 1, and now you again increment your j to the next, and you again increment your frequency, and now you can see that 2 is making a pair with the previous element. You can see that 2 is making a pair with the previous element, so you update your pair. That is, you can add that frequency minus 1 to your pairs, right? See, what I was saying is, you should add this frequency of your current element, minus 1. You should add this. So if you can add this, you are automatically counting the number of pairs, right? So after you're adding that pairs, you can again check with the k. Since it is satisfying the condition, since there are at least k pairs in this subarray, now can I say it is a count of one good subarray, right? So what we will do, we'll update our count to 1. uh can I say all the subarrays, all the length which is having to the right side of it, all are good subarrays? Because it is, if I'm saying this is one good subarray, can I say whatever the elements are existing in my right side, if I can extend the window, all subarrays will be a good subarrays, because it is already containing two pairs. Even if I'm extending, it will still satisfy my condition. It will still satisfy my condition. So, so what I was saying, wait, so see, if I'm saying, it satisfies my k pairs, can I say this length is also satisfy my pairs? If there are any extra length, even that window, starting from the first element, ending to that, can I say they also satisfy? Because all there are already at least k pairs in this window. Even if you extend this window, it will still contain your k pairs in it. So what you'll do, so if it satisfies your condition, just count number of possibilities to the right. Because see, this can be your one good subarray and this can be your another good subarray, right? You can say it directly, because there are already k pairs already satisfied in this first window. So now you can extend and you can add directly without checking to the right side, without checking to the right side. So what you'll do, you just update your count with these two elements. How can you get that? That is n minus j. You should add the count. You should add the count with n minus j. That is 7 minus 5 will give you 2, right? Because these two are good subarrays. Starting from the 0, these two are good subarrays, and you can observe that. And you can observe that. Now, you after you got your good subarrays, now your iterator j will comes into the picture. Now you can see, you just increment your I and decrement the count of decrement the count, or the frequency of the element which has standard, which was in which the eye was standing on. Then since, see, you got to decrement your 3's frequency to 1, and you can check, if you're removing 3, can I say you need to remove one pair, because it is forming one pair with the another 3, right? So your pairs should become 2 to 1, right? So sorry, it should become 2 to 1, right? Then, yeah, then your I will stand on the next, and you can again check your k is not satisfying with your pairs. So what you will do, you just increment your j to the next one. Now you can increment your j to the next one. Now your force frequency will become 2. Your force frequency will become 2. And now you add the pairs with the frequency of 4 minus 1. That is 2 minus 1. That is 1, right? So 1 plus 1 will give you a total of 2. So 1 plus 1 will give you a total of 2. Now you can see this window is satisfying. Now you can see this k. No, sorry. Yeah, now you can see this window. Yeah, this window is satisfying your k pairs. This window is satisfying your k pairs. So now, wow, what you need to add in your count, that is n minus j. That is n minus j. What is n minus j? That is 7 minus 6, right? So you need to add a total count of 1. That is, total will become 3, right? So you understood, right, why I was adding n minus j? because all the subarrays, by extending to the right side of it, will we can add directly. Because if there exists any element, let us say some 7 or something, if it is already containing k pairs in it, even after extending that, you are able to still contain that k pairs. So that's why you can add directly n minus j pairs to your count, right? N minus j subarrays to the count, right? So that's what I was telling. Now your count is 3 and your pairs are 2, right? Now you are having two pairs. Now you are having two pairs. Now you again increment your I to the next one and you decrement the count. Now you decrement the frequency of 1 to 0, and you can see it is not forming any pair. You just increment your I to the next one, and now you again, since it is satisfying, you should update your count to 4, right? You should update your count to 4. So now you just keep on repeating this process. Once after you cross this line, uh, there will be not enough pairs your that it should satisfy your k, right? So since it is not having that, you'll just left with the count of 4, and now you can return your count as 4. See, I'll just explain the test case 1. Since it is having okay, yeah, since it is having 5 ones, 1 2 3 4 5, yeah, our k equal to 10, right? Our k equal to 10 and n equal to 5, and n is equal to 5, right? So what we will do, initially we'll take the pairs as 0 and the count as 0, and the count as 0. Now you see, I'm gonna update my frequency here. Still there is a one element, I was updating the frequency. Now you take the two iterators on the first element, that is your I and j, and now can I say, you gotta add the frequency, you gotta increment the frequency of 1 with 1, and now you add the pairs, number of pairs, how many pairs that the starting one form, that is frequency minus 1, that is equal to 0, right? Plus 0. Now you increment your j and increment your frequency to 2, and now how many pairs that this one is making? That is 1, right? That is nothing but frequency minus 1. That is plus 1, right? That is plus 1. Now you again increment your iterator to the next point. Now your frequency will become 3. And now how many pairs that this one is making? This one is making two pairs with the previous elements. Two pairs with the previous elements, right? So you add frequency minus 1 to your pairs. That is two pairs. Still it is not satisfying your k. That is equal to, it should have 10 pairs, right? Now you again increment your j to the next one, and you again increment your frequency to 4, and now you again check, it is forming a three pairs with the previous elements. So you add frequency minus 1 to your pairs, so it is having a total of 6. Still it is not satisfying the condition. You again increment your j to the next, and you again check, it is, your frequency will become 5, and now you'll add four pairs to the total pairs, because it is forming a 4 pairs with the previous ones. Now you can check the total is satisfying our k. Now you can check the total is satisfying our k. Since it is satisfying, now you should add, how much you need to add, count, that is n minus j. It is nothing but 5 minus 4, that equal to 1, right? That equal to 1. So after your count becomes 1, now now your iterator, I will comes into the picture. Now after incrementing your I, you need to you need to decrease the frequency of that element. Then once frequency will become 4, and now you need to remove all the pairs whatever it is forming with the elements, because see, this one is making a pair with this one and this one and this one and this one. So you need to remove all the pairs, since you are removing this element from your window. Now, see, after decrementing your frequency, can I say you need to remove that much? You need to remove that frequency into your pairs, in that pairs, right? See, I'll just erase this. Now, after you have a total a frequency of 5, there are 10 pairs with you, and the count is 1, right? And the count is 1. So, after you have incremented your I, you have removed that element from your window. Then your frequency becomes 4, and now you need to remove that many pairs from your total pairs. Why? Because it is forming that much pairs. So you need to remove that frequency. That then your total pairs will become 6. You can see that is not satisfying your condition, and you can leave here, right? So if, see, you need to check like if you're incrementing your I to the next one, you need to decrement the frequency, and you need to remove whatever the pairs that it was making with the forward elements also, because all these elements are making a pair with this. So you need to even remove those pairs from your total pair summation. So if anyone wants the code, I can show you. The code is pretty simple. See, initially I'm taking a pairs, which I'm counting the total pairs, and this is our count. That counts the number of total good subarrays. So you'll take the frequencies of each element in this map. See, initially what I was doing, initially this pairs, if these pairs are satisfying, see, if there are total pairs such that it satisfies our k, then I'm adding the count, which is n minus j plus 1, because all the right subarrays, by extending that, we can get that, right? So I'm adding that count to my count variable. And what I was doing, I was just, after it satisfies my condition, I just increment my I, and I just remove all the pairs whatever my current element is forming, and then I was just decrementing the frequency of my current element. Then I'll just move forward. And what if there are not at least k pairs, then what I was doing, I was just incrementing my frequency of that element, and I'm adding the pairs, whatever the pairs that it was making with the previous elements. So you just increment your j. So whenever your j is equal to n, see, you can ask me, even here you can keep j is less than n. So why I was not doing like that is, even if you reach the end, like I can see you here. Yeah, even if you reach the end, if your I is at starting, even you need to check whether the answer is possible by shrinking or eliminating the starting element or not. Even if you're at this position, uh, you have completed iterating all the elements, still you need to check whether the eliminating the starting elements, the answer is possible or not, whether you are getting the count or not. So for that purpose, I have just run a loop without that condition. See, if your j is equal to n, and then see here, once if your j becomes n, then it'll go to this if case, and then it'll check whether your frequency is greater than that or not. If it satisfies, it'll run into that loop, or otherwise it'll comes to the else case. Then it just breaks. Then it just breaks. So I can just quickly submit this. Oh, see, you see, it's working. It's working fine. So if you understand this, just please, please, please do make a like and subscribe.